Yeah, like post-lunch talks, you makes you really feel sleepy. And now I will try that I don't make you, put it in another zone and try to explain what I could. Who am I? I'm founder and CEO at 112. We are a reliability and backend product engineering company based out of Pune. It's been 12 plus years for me, mostly work with startups and a lot of SMEs. I have evolved from a young engineer from buzzword driven development to impact driven development. But by the way, disclaimer, there will be a lot of buzzword that I try to explain as in the course of the journey. I love CrossFit and powerlifting. Recently got into recently my cooking.
Yeah, it's okay.
Yeah. Yeah. So recently got into long distance running. So jokingly, my wife says that, hey, you are having your midlife crisis. And I tell her that, no, I'm going to live like 100 years and I'm 35, I still 15 years to go. And deep down, I know that she's right, not because she's my wife, but I know my tech bros and sisters in the tech community. So, yeah. Problem statement. What actually and where it started from. So I am kind of responsible to run the hiring pipeline at 1-2N, and it's really fun when engineers run hiring. And I was sitting with my recruitment team and this thought, again, in this whole space of chat GPTs and RAGs and whatnot, can I actually help my recruitment team to identify engineers based on certain skill sets? Okay. And can an interactive application help us? All right, yeah, okay, doable, right? You have a lot of your OpenAI and Cloud wrapper, definitely can build it, and they are really efficient, which are right now in the market. But again, this was something for our own curiosity, is that, hey, I individually have worked building and hosting solutions in data centers and running distributed components there. And it's a very different engineering challenge that comes when you are not in cloud. Right? For example, your any 3-node cluster that you have to run, the maintenance also comes on you. So just from there, out of curiosity, what it will take to actually just self-host these LLMs on our own, right? And yeah, this was the problem statement. This is where we started. Right? Now the story that actually looks like we initially explored the framework during our initial days, like what all actually exists in the market. And by the way, I'm telling you, this is from ground zero, and this is just pure RF experimentation. So this number is nothing that we did it on production. This was for pure fun and curiosity. What are the learnings and the challenges that we actually faced in the course of the journey? Right. Journey of moving to Kubernetes? Well, why not? If the guy next door who is running WordPress can ship it on Kubernetes, why can't I run my LLM there? Exploring vector databases for the RAG architecture, retrieval augmented generation architectures that we call it, and the lab setup for deploying these RAG architectures. Finally, the overall learnings that we had for the ecosystem. Some of the takeaways, which I believe can help after this talk, is what are the tools to run your self-hosted LLMs? Running self-hosted LLMs on affordable GPU machine. I think cost is the one major factor that keep on coming. And creating an operational homeland. So ground zero, as I told you, started with, hey, this is MLOps. When MLOps is machine learning operation, which basically helps to productionize machine learning models, right? And the actors involved are like data scientists and ML engineers. More than a decade old thing, we're pretty much sorted now. And we did some work around this as well. And we thought, hey, LLMOps is the new MLOps. All right, okay, cool. So basically, I said that there will be an application which takes resume as an input, takes a job description, suggests right candidates that matches the job description. But then we were not aware about the tools and the ecosystems and the dependencies there, right? In fact, we were not even clear what does a RAG architecture looks like, right? So there were like zero visibility. But then, fine, okay. Now, drawing parallels. I think as software engineers and people in technology, if you have to actually, if you are like senior enough, you've spent enough time in tech, you try to draw parallels based on on an existing mental model. For example, learning a new programming language. You know an existing programming language and try to do this, right or wrong, that's the subject to discussion, but it is much more easier, right, as humans. So something like this. A traditional 3-tier web application, you have a front end, you have a back end, you have a database server. A model serving by a web server, which is your chat interactive application or your RAG application, you have your front end, you have a back end, you have some server. Okay, this was the fill in the blanks. So model serving is equals to HTTP request serving. Is it like that? That was the first question. Web app is equals to IO bound, which can scale linearly. But what about your RAG application? So these were these questions that we had initially. Pretty simple diagram. No rocket science, everybody knows. HTTP request response, there is an API server, there is a database. Now, when we were actually exploring, there were two terminologies that we got introduced. One is inference and inferencing, and the other one is serving. Right? Now, mind you, this is like software engineers trying to build their own, mental model. If I give an analogy, a 3-tier web application is network I/O bound, but LLM model serving is more memory and CPU intensive, right? So a single web server accessing a database can achieve 10,000 queries per second, but your models would be just 10 requests, right? Because it requires a very heavy hardware. Now the models are loaded once in the life cycle of the process, which is similar to database connection too. Right? So there are some similarities, but there was something which were like, really different. And so when I said that, okay, there is like inferencing serving, I'm going to just talk something about this inferencing part. So inferencing, basically, there's a sequence of tokens from T1 to T8, right? And you have your input prompt tokens, which you can see on the yellow side, on the right-hand side, and there is an iteration that goes in there. Now, there is something, whenever there's an input token, the next sequence is the generated, the ones is the blue. And finally, there is a stop token, which is the end of the sequence token, right? This is an iterative process, which is like responsible for just the prediction part, right? That is fundamentally what we have. Now, there is this concept of static patching. Now, if you look at it, what happens is that if there is a sequence like from T1 to T8, and you have 4 sequences, they are being generated here, and if you look at on the right hand side, there are sequences where end of sequence tokens are ending at different lengths. So there is a T6, T8, T5, T7. Right? Now, if you look at these gaps, there is still the GPU hardware is still not utilized. So they are actually kind of memory bound. Now, LLM inference is mostly memory bound. Why? Because loading of your 1 MB of data actually takes longer than doing the computation via the GPU cores, right? And also, if you know, as we say, the numbers that you should know for your CPU, there is also an interesting GitHub link for the numbers you should know for your GPUs. So the memory requirements of GPU is like close to 16-bit, which is like 2 bytes per parameter. So when somebody says that, hey, this is a 7 billion parameter or 8 billion Llama 3 parameter, the footprint that we really look at it is like 14 GB or 16 GB, right? So there is still a chance of doing up a memory optimization. Now, so memory optimization first is a concept of quantization, which I will just stay with the definition, like moving from a 16-bit representation to an 8-bit representation or a 4-bit representation. But basically, then you are trading off in terms of the accuracy of it, right? But the other one is you use optimized inferencing server like VLLM, which is an open source one, and that is what we opted. Why? Because we read about it, we read about the papers and understood. So there is, because they implement 2 things. One is paged attention, and the other one is continuous batching. By the way, continuous batching is also used by a lot of your specialized inferencing servers like Triton, right? Now VLLM page attention. Now basically it takes like your input tokens and produces attention key and value tensor. And key and value tensors are actually stored in your key value function. So if you don't have this paged attention because of the numbers that was there in the paper itself, then you are almost losing out on 60 to 80% of your memory. There is a memory wastage. While there is like one sequence that's being processed by the GPU. Now, page attention is mostly on the concepts of virtual memory and actually paging. And basically, this is the ability to store your continuous keys and values in the non-continuous mode. So coming back to the continuous batching, so this was a static batching on the left-hand side. And on the right-hand side, if you see that there is an S6, S5 and S7. So what happens is that S6, S5 and S7 doesn't wait for S1 and S4 to complete the complete the iterations. They actually can be done in the same batch, and hence this concept of continuous batching actually. So the other one was serving, right? So basically serving is the idea of serving a model as in production, and end-to-end production there is scaling, there is monitoring, security, API management, all of it, everything that has to be taken care, right? Besides the inferencing part. And one of the tools that we work with is called Racer. Now Racer is actually a component of something called as Ray. Ray is like your open source distributed computing framework in Python. But still something like if you work around a big data ecosystem, like you have Apache Spark, you have your workers and you can just scale it. The good part with Ray that we came across is that you can scale programmatically without depending on your DevOps practitioners. It provides you the HTTP request interface that you can, it just makes it very friendly because it's a REST and HTTP request. The dynamic routing part, right? So you route to different model versions. Like there is one challenge, right? Whenever you are thinking, hey, if I think of a microservices kind of an architecture, there is a reverse proxy and you send up a request to different service. But if you have to do something for models, Racer kind of helps with your A/B testing or kind of your camera. Now, if I summarize, that serving is the superset, inferencing is the subset of your whole request. Now, switching back to the RAG application that we have, right? The input queries, a typical RAG application will have the serving, where you have the front end call making the call to the backend and getting certain profiles, right? So this was the serving part of it. Now, inferencing, it basically takes the job description as input, process tokens, and then finally producing the output. So this is where it actually started to come off some scale. So we were running this in virtual machine, but then of course I'm old school and I thought, hey, is there anything like a platform as a service like Hero, right? So then we got introduced something called to as transition to Bento ML. If you see at the background, there is a Bento box where like everything is part of. It's like everything is packaged for you, but like think Heroku, but to host your LLM models, right? So model packaging with all the necessary dependencies. You're providing up an API server, API endpoint. Everything is actually taken care by Bento. Again, this was also one experiment before we started to go into the Kubernetes and all of that ecosystem, just exploring that aspect, right? And it also provides the first class support for observability. What were the learnings, right? So we had our own hot dogs and no hot dog moments, right? I mean, they were kind of functional, but like didn't make any sense to it. So some of the problems that we faced while we were allocating the GPU resources, right? This is a Ray framework that we are using. There is a function, there is a decorator, and the resources is like allocating completely. But what we were missing out was on serving the concurrent request. So one of the things that we had to identify that you can actually the topic that I said that you can scale it programmatically is via this functions. So you process PDF, provide the GPUs in a fashion, and we were able to at least handle like 2 requests at a time with a single GPU. My GPU is also actual hardware. The other part, the problem that we had was the limited network bandwidth for the GPU provider. So we started using Kubernetes initial days. We were working with the guys, and of course, when you get a first hand of actually proper LLM GPUs, it's super exciting, right? The first experience was great, but the problem was that every day we wanted to save on the cost. What we wrote some automation, but whenever we used to bring it up, the footprint was like 8 GB, and it used to take a lot of time. So the download speed was like 150 to 300 kbps per hour. So the other solution is that we move to a different GPU provider in India, which is E2. And then the problem was is the installation with PIP. So Python's package manager installation without cache, by the way, was taking like 5 hours for us to do something. So how we solved it? We actually used UV, which is a drop-in replacement of PIP, written in Rust, and brought down the download and installation time for us by 60%. So I think when we whole started this thing that hey, MLOps is the new LLMOps, it kind of 1.5 months down the line, it just shattered for us. Right? There were a lot of buzzwords. There was one application which was not even working, and we kind of realized that hey, how LLMOps is actually different from MLOps. There are multiple factors in the size of the models and whatnot. But the 2 aspects that I want to cover is in the infrastructure and the deployment. So in the infrastructure, because of the sheer size of the the LLM models and the kind of hardware that it requires, it just makes very different ball altogether. And in terms of the deployment that we see, for MLOps, it's pretty much sorted and streamlined. If you see that your typical loop or your DevOps, MLOps kind of a loop, it is standardized. But LLMOps, in my opinion, what is actually trying to figure out, and there is no certain kind of a standardization at this moment. Everyone has their own custom solution. So whomsoever I talk to people, and they are also like just putting up everything at their own. Then the journey was actually from the virtual machines to the Kubernetes by happening, right? Now, very important factor is the NVIDIA GPU operator. But I don't want to talk about the components, but I think what it actually helped. If you have to do up a manual installation, and if the GPU operator did not exist, first of all, the GPU operator helped to identify GPU as a resource on a Kubernetes ecosystem, how your compute and memory is. But if you do have the manual installation, you will have to have the drivers, runtime, Kubernetes, and whatnot. On the right hand side, there will be a lot of, it takes care of a lot of things for you. So we were operating on Ray, then we moved to Kubernetes. We actually, worked directly. We were using this self-hosted Kubernetes and used Kubernetes on top. So I want to introduce another thing, which is called Kubeflow, that we actually explored. Now what happened was I told you about Bento, right? But think Bento, that has to be also self-hosted for Kubernetes. But this was, the complete end-to-end pipeline just on the Kubernetes. It's an ecosystem of your open source projects, right? And it's used primarily for your machine learning models, and the complete end-to-end pipeline is taken care by you. If you look at it, it actually has everything from a Jupyter notebook to your TensorFlows to your Hugging Face. Everything is actually clubbed together, so it becomes quite a beast to manage, and that also introduces some sort of challenges for us. Now, challenges with the Kubeflow while we were actually exploring. First is the very high effort to actually streamline things for our self-managed Kubernetes. It takes it took us a lot of time. We went to multiple rabbit holes there. If you are on an easier managed Kubernetes, it is still okay because a lot of the public cloud providers, they kind of have their own help charts which can be deployed at their end. But the another thing that nuances that we built in, that probably there are a lot of conflict of interest where these projects were still not maintained by the cloud providers themselves, like to integrate Qflow into their ecosystem. So actually, while we were working at that point of time, 2 months back, there was a PR, which was raised. So while we were having a challenge of migrating Ray into Qflow because that is what we worked with and we got a knowledge base, we thought it can be, because the documentation says that you can actually plug and play. But when we tried doing it, there were a lot of issues that we faced because Qflow comes with their own flavor of Ray, and it was not decoupled. It was very tightly coupled. So we were facing a lot of semantic versioning issues. Even a patch version was actually, creating a havoc. This is something that we did not try, but again, based out of the readings and everywhere. So there is a project called Flight, which is now much more used in the community than the Qflow. I haven't tried it, but yeah, still need to actively. So we got into the vector stores, right? The interesting part. Vector stores as a concept has got your embeddings, which converts. So from your traditional like keyword searching, vector stores moved into this whole semantic-based searching based on the embeddings that are created, right? So you have your embeddings where you convert the text data into some numerical representations. Storage basically are stored in your vector store. Right? Then you have a query which is converted into an embedding, and then finally you have your retrieval, which is like getting the results or the semantic search that effectively it does. What were the options that we explored? First is the FAISS, which is Facebook's AI similarity search. Now, to just give you an analogy, like think of it like your in-memory embedded database is like RocksDB, something like that, which is in-memory, does your in-memory search. It only kind of stores embeddings of it, not the actual content, right? So this was this one challenge that, not the challenge I would say, but this is what we explored during our initiatives. Then the second one, we tried to have a persistence with Qdret, and Qdret was basically, over the network you can host it. So we moved to Qdret back then, and it kind of stores your original content with the embeddings itself. So it has a fancy UI and whatnot, and you can look it. Now, what is the most interesting part? The lab. So again, like it doesn't hurt when you know you are poor, but it hurts when somebody tells you that you are poor. And this is what happened when AWS told me that you are poor. Because when we try to have like our machines spin up on AWS, this just refused that hey, your cloud bill is like doesn't meet a criteria, you won't get any machine. We tried in all the regions because initially it was thought that okay, even if we have to pump in money, let's do it. But we could not get those GPU machines. And hence you say we were also GPU poor in the picture. So I'm doing just a cost comparison here. If you look at it at the top right, these were the NVIDIA V100, like really good top-notch machines. The cost coming up was like $1.18 an hour. This was close to $2. If you start comparing it to the AWS ones, the basic ones are like almost 3 times or 1.5 times. But as and when you grow for a V100, which is of the similar configuration, this is close to like 6x or almost close to 10x of it. Right? We also looked at Bento-ML because Bento-ML also provides the GPUs and the price comparison there as well. You can observe, right? So the whole lab, what it was for us. So we basically, we have our office in Pune, and there were like remote developers who were working. We just connected it via the TL scale. So we had this one node where we were hosting the quadrant database and the embedding models. The other one was an XPS machine. We were running our kind cluster to host these LLMs and GPUs. Now next is the NVIDIA V100 lab on the E2E networks. So we thought that, hey, let's pick up one single huge gigantic instance and set up everything with kind, one control plane, two workers within the same host, and installed everything out there. The Kubernetes cluster lab on the E2E networks, which was like this. You have this, let's actually have a self-hosted proper Kubernetes cluster. But then again, so the interesting fact was that while we were trying to have the managed Kubernetes cluster from E2E, we could not actually get the GPU machines because it was not supported. So we, bite the bullet, actually created like 3 machines, a simple control plane, single node control plane, and 2 workers where there were like multiple, GPUs that we attached to actually run our workload and see how things actually operate. Now, if I bring it all together through the RAG application we have, like if you look at the internet, the green part was actually missing for us, and it was a typical RAG architecture that you see everywhere, right? Multiple blocks. I also went through it. But what it actually helped us to put things in place that, hey, what does this component looks like? What does this component looks like? What does this component looks like? And what are they actually doing on the ground? Right? I'll just summarize all of it. Okay. In the opinion of our 3 months of our experimentation and everything, while your LLM models are still growing, amazing. There are a lot of open source ones and that are coming. But the tool chain of the operations is still kind of, I won't say broken, still nascent. It is growing day in, day out. Okay. And it will still take some time while we are there. We are also working on it to actually streamline things as a thought process. Even if we have to stitch things initially, but how it will actually pan out if it will be standardized. Some other things that we realized, right? There are a lot of alternatives to public cloud for GPUs. There are available. For sure, you can find a lot of cheaper GPU options. But the only challenge will be, don't treat them as clouds, treat them as like machines which just provide you GPUs, because you will end up writing a lot of your custom code and automation. Because if you have to have that automation kind of thing. One important point here is that the PaaS providers, for example, like a Bento ML or a Together kind of AI, which not only provide the software stack, they also have this GPU with them. So renting pure GPUs, this is again the opinion that we observed. It is much more easier to self-host it on a PaaS provider rather than trying to rent GPUs and self-host everything from your end. Your API-based LLM is easy for sure. You can definitely have your multiple applications, but this is more about hey, how do I do up a self-hosting? And self-hosted LLM has a lot of entry barriers, and it will still take some time to actually reach that stage. And there, by the way, there are a lot of companies trying to build their muscle internally, but requires a lot of deep investment and pockets. These are some of the resources. I really suggest that please read about the VLLM implementation of page attention and how they did it. This is like almost 1.5 years back paper, but interesting. And the number every LLM developer should know. It's really interesting. You should back of the hand numbers that will come. Cool. That's it. Thank you.
Thank you, Jaideep. We have more than enough time for some questions, and this is a bit of an interactive topic, new one. So, if you have any questions, please raise your hand and come up.
More on how LLMOps is easier on managed Kubernetes.
So what happens? So what happens is the LLMOps on the managed Kubernetes. It was more relevant to the Kubeflow part, because deploying, if you have to deploy Kubeflow there, they have a very specific set of version that is already done. You can also do that. You can also set up Kubeflow on your own management duties, but it will require much more effort to actually streamline because we were in a rabbit hole of version mismatch and whatnot of different packages that we were trying to club.
So do you mean managed Kubernetes? People managing Kubernetes, they have streamlined the process. I mean,
No, the cloud providers provide their own kind of health charts and everything like that.
so why can't we use the
You can use that, but they are like very specific to that particular cloud provider.
Okay. Sorry, one follow. Yeah, can you give an example of cloud provider?
AWS has it.
And what charts would you?
For the Kubeflow installation.
Okay.
Yeah.
I'll check.
Any other questions? If nothing struck at this point, then I think we'll wait for the cup to be processed and Jaideep will be around in the common area as well. Sure, right? Yeah. Thank you so much, Jaideep.